Welcome to this tutorial on the Splunk Script Command. The script command is a powerful feature in Splunk processing language that allows you to execute external scripts directly from your SPL searches. This command enables you to run Python, Perl, or Shell scripts while processing search results, extending Splunk's native capabilities with custom logic and external processing power. The basic syntax is simple. You use the pipe symbol followed by the word script, then specify your interpreter and script name. This opens up endless possibilities for data transformation, enrichment, and custom processing within your Splunk environment. The script command follows a straightforward syntax pattern. You start with the pipe symbol to chain it with other SPL commands, followed by the word script, then specify the interpreter you want to use, and finally provide the script name. For example, to run a Python script, you would write pipe script python myscript.py. For Perl scripts, it would be pipe script perl process.pl. The command seamlessly integrates into your search pipeline, taking the output from previous commands and passing it to your external script for processing. Your script receives the data, processes it, and returns the results back to the Splunk pipeline for further analysis. The script command supports three main execution methods, each suited for different types of processing tasks. Python scripts are excellent for data processing, statistical analysis, and complex transformations. You execute them using pipe script python followed by your script name. Python's rich ecosystem of libraries makes it perfect for advanced data manipulation and machine learning tasks. Perl scripts excel at text manipulation and pattern matching operations. You run them with pipe script Perl followed by your script name. Perl's powerful regular expression capabilities make it ideal for log parsing and text processing tasks. Both interpreters provide robust solutions for extending Splunk's functionality with custom processing logic. Before using the script command, you need to properly configure your environment. For file setup, your scripts must be located in the bin directory of your Splunk app. The scripts need executable permissions set on the file system, and you must configure the commands.onf file to register your script with Splunk. For script format requirements, your script must be designed to read from standard input in CSV format, which is how Splunk passes data to external scripts. The script should process this data and write results back to standard output, also in CSV format. It's crucial that your script properly handles the header row to maintain data structure consistency throughout the processing pipeline. Here's a practical example of a Python script for use with the script command. The script starts by importing the CSV and sys modules for handling comma-separated values and system input-output operations. The main processing loop reads each row from standard input using csv.reader and sys.stin. For each row, you can implement your custom processing logic. In this example, we're adding a new field called new_field with the value processed. Finally, the script outputs the modified data using print and CSV writer. To use this script in your SPL search, you would write pipe script python process_data.py. This allows you to seamlessly integrate custom Python logic into your Splunk data processing workflow. This Perl script example demonstrates text filtering capabilities using the script command. The script begins with the standard Perl shebang line and uses the strict pragma for better coding practices. The main processing loop reads from standard input line by line using the angle bracket operator. Each line is automatically stored in the default variable $_. The chomp function removes trailing new line characters to clean up the data. The script then applies text transformations, in this example, using a substitution operator to replace all occurrences of the word old with new using the global flag. Finally, each process line is printed with a new line character. To execute this script in Splunk, you would use pipe script perl text_filtered.pl in your search pipeline. This shell script example shows how to process log entries using basic shell commands. The script starts with the bash shebang to specify the shell interpreter. The main processing is handled by a while loop that reads input line by line using the read command. storing each line in a variable called line. Inside the loop, the script processes each log entry using common Unix tools. In this example, the echo command outputs the line content, which is then piped to the set command for text substitution. The set command uses the s/error/critical/g pattern to replace all occurrences of error with critical in the log data. To use this shell script in your Splunk search, you would write pipe script sh_log_processor8. This demonstrates how you can leverage the power of Unix shell tools within your Splunk data processing pipeline. Let's wrap up with essential best practices for using the script command effectively. First, always set proper script permissions using chmod to ensure your scripts are executable by the Splunk process. Second, handle CSV input and output correctly by properly parsing the header row and maintaining consistent field structures. Third, optimize your scripts for large datasets by using efficient algorithms and avoiding memory-intensive operations that could impact Splunk performance. Fourth, thoroughly test your scripts with various data scenarios before deploying them in production environments. The script command enables powerful external processing capabilities, supporting Python for advanced data analysis, Perl for text manipulation, and shell scripts for system-level operations. This seamless integration with the SPL pipeline allows you to extend Splunk's functionality with custom processing logic, making it an invaluable tool for advanced data processing and analysis tasks. If you like this video, hit that like button and don't forget to subscribe. Visit CodeLucky.com for more such useful content.